Okay, welcome back to Mr. Hassan's Maths channel. I'm going to be answering here question number 9 from the Solomon I collection of pure mathematics papers from the old C1, which is now P1. So this is from the old Solomon collection. This is Solomon I from the Edexcel papers, and I've called this question 8 in my end of topic worksheet, number 8, differentiation from P1. And here we're told about a curve which has equation y equals x cubed minus 5x squared plus 7x. And we want to show that the curve only crosses the x-axis at one point. So we've got to show that this crosses the x-axis at one point and one point alone. So something crosses the x-axis. When something crosses the x-axis, well, that's when y equals 0. On the x-axis, all the y coordinates are 0. Okay, every point here will have a coordinate, something 0. So the y coordinate is 0 on the x-axis. So if we replace the y in the equation with 0, it will tell us the x values where this crosses the x-axis. So we have x cubed minus 5x squared plus 7x equals 0. So finding the places where something crosses the x-axis, okay, is found by making the y coordinate 0, taking y as 0. So now we can factorize this by taking out a common factor of x. So you have x times x squared minus 5x plus 7 equals 0. So we have x equals 0. So we see it crosses the x-axis at one point, x equals 0. Now, how can we prove that it doesn't cross it in any other points? Well, to solve this equation here, we have a product of two factors equals 0. So either one of them is 0 or the other one is 0. So then the other places where this may cross the x-axis would be found if we equate the other factor to 0, because either x is 0 or this factor is 0. Now, we've got to show now basically that this has no solution, right? So we're not going to try and bother factorizing it, because obviously we know that it won't have any solutions because the question tells us it won't. But how do we prove that it has no solutions? Well, this has now become this bit here is now a quadratic equation. And how do you show that a quadratic has no solutions? Well, you find its discriminant and you show that the discriminant is less than 0. So we're going to find what b squared minus 4ac is for this. So we're going to look at the discriminant, okay, which is b squared minus 4ac. So here a is equal to 1, the coefficient of x, b is equal to negative 5, and c is equal to 7. So here we're going to have b squared, which is minus 5 squared, minus 4 times a, which is 1, times c, which is 7. So you end up with 25 minus 4 sevens are 28, equals negative 3. So we can say that as b squared minus 4ac is less than 0, therefore there is no solution. There's no solution for this equation, x squared minus 5x plus 7 equals 0. Therefore, x equals 0 is the only solution. Okay, or you can say there is the only solution, and y equals x cubed minus 5x squared plus 7x. Okay, crosses the x-axis once only. Okay, so it's important for you to make some sort of qualifying statement. Don't just leave it as minus 3 here. You should mention that because the discriminant is negative, as it's less than 0, therefore there's no solution to this part of this, equation here, and therefore the original equation only crosses the x-axis at one point when x equals 0. Okay, so that's important for you to make those points there. It's very, very important. Okay, that's part A done. Now for part B, it says the point P on the curve has coordinates 3, 3. Find an equation for the normal to the curve at P, giving your answer in the form ax plus by plus c, ax plus by equals c, where a, b, and c are integers. So we have y equals x cubed minus 5x squared plus 7x. So the curve is y equals x cubed minus 5x squared plus 7x. Let's make sure we're in that round. Okay, that's the equation. So the point P on this curve has the coordinates 3, 3. So we know the coordinates, x and y coordinates of the point P. We're going to find an equation to the normal to the curve at P. Okay, so I'm just drawing just a section of a curve. I don't know if it's realistic, but just supposing this was the point P. Okay, just supposing this is a point P. Okay, if this is the point P, okay, then this line, which just brushes past the point curve at P without cutting through the curve, this has the same gradient as the curve at point P. Okay, it has the same gradient of the curve at point P. Now, the normal to a curve is a straight line which passes through the curve, okay, perpendicular to the tangent at that point. Okay, so this would be the tangent and this would be the normal. So we want to find the gradient, the equation of this normal line. This is the line which is the normal. We want to find the equation of the normal line, okay, in this form. Okay, so it's a straight line. It passes through the point P, so we know a point that it passes through. The other thing we need to know is the gradient of the normal. Okay, to find the equation of a straight line, we need two things. We need a point on the line and we need the gradient of the line. Okay, so for us to find the gradient of this line, okay, this normal line, we understand that it's perpendicular to the tangent, and perpendicular lines, they are related to each other in terms of the gradients being negative reciprocals. If you find the product is -1. So if I know the gradient of one line, I can know the gradient of a line perpendicular to it by changing its sign and turning the fraction upside down. So for me to find the gradient of this normal line, I need to find the gradient of the tangent. And to find the gradient of the tangent, well, I can find the gradient of this curve, or the gradient function for this curve, which is dy dx. So I have y equals x cubed minus 5x squared plus 7x. Now I can find the gradient of this curve by factorizing this, by differentiating this. Okay, that will be the gradient function. When you differentiate a function, you find its gradient function, which tells you the gradient of that function at any point. So when I differentiate this, I get 3x squared minus 10x plus 7. All right, so now I want to find when the gradient, or what the gradient is at the point P. So I can say that at the point P, you know, x equals 3. So the gradient of this curve when x equals 3 can be found by substituting x equals 3 into this gradient function. That tells us the gradient of the curve at that point. So 3 times 3 squared minus 10 times 3 plus 7. That's 3 times 9, which is 27. Okay, and that's 10 times 3, which is 30, plus 7. So that's going to give us negative 3 plus 7, which is 4. Right? Minus 3 plus 7, 4. So we can say that the gradient of the tangent is equal to 4. Therefore, the gradient of the normal is equal to its negative reciprocal, which is minus a quarter. All right, to find the gradient of the normal, you take the gradient of the tangent, which is like 4 over 1. You change its sign and you turn it upside down. That's, if you multiply these two together, you get -1. The product of perpendicular tangents is always -1. Okay, so now I know the point on the curve, which is 3, 3, and I know the gradient of the line. So I know the point on the line, and I know the gradient of the line minus a quarter. I can now use my formula y. I've got no space there. Let me do it over here quickly. All right, so I know y minus y1 equals m times x minus x1, and we want everything to be integer. So if we've got y minus 3 equals negative a quarter times x minus 3. As we want to express it in this form where we want everything to be integer, I can multiply both sides by 4 to get rid of the fraction. So I have 4y minus 12 equals, now the 4 is going to go out, I've got -1 left, so minus x plus 3. And we want to bring all the terms x and y on one side and the numbers on the other side. So I'm going to add x to both sides. So I have x plus 4y equals, and I'm going to add 12 to both sides, equals 3 plus 12, which is 15. So x plus 4y equals 15. That is the equation of the normal. That's the equation of the normal line. Okay, so there's the answer to question, whatever it was, I think 9 part B. Okay, from this Solomon paper. Now, the last part of the question says the normal to the curve at P meets the coordinate axes at X and R. Show that the triangle OQR, where O is the origin, has area 28 and 1/8. So we know that X plus 4Y equals 15 is the equation of the normal line. Okay, so first of all, let's find the coordinates of Q and R. All right, it meets the x-axis at Q, well, the coordinate axis at Q, and they didn't tell us which is which, so it means, let's see where it meets the x-axis. It meets the x-axis, okay, of course, as we mentioned earlier, something hits the x-axis when y equals 0, and something hits the y-axis when x equals 0. So when I find where it hits the x-axis, I'm going to put y equals 0, so I have x equals 15. When I find where it hits the y-axis, I'm going to put y equals 0, x equals 0, so I have 4y equals 15. Okay, so 4y equals 15, so therefore y equals 15 over 4, which is like, that's 3 3/4, you could say, because I'll just write it as 3 3/4 for now, and I'll leave it like this when I show it. So now we can see that it crosses the two axes at those 2 points. Okay, let's do it this way. So, 1 second. So we have here, I'm just going to make a sketch to make it clearer. We have, it crosses the x-axis at 15 and the y-axis at 3 3/4, which is 15 over 4. All right, so this is the line going through those points. Okay, it cuts the x-axis at that point, and well, one of them is P, one of them is Q. It doesn't tell us which is which. Coordinate axis at Q and R. Let's say this is Q and let's say this is R. It doesn't really matter, and this is O. Okay, so it says show that the triangle OQR, where O is origin, has this area. Okay, so we know that this is a right angle because this is where the x and the y-axis meet at right angles. So it's a right angle triangle. So we can say the area equals a half times the base, which is 15, times the height, which is 15 over 4. Okay, a half times the base times the height, which gives you 15 times 15 over 4 times a half. Let me just, it's a bit messy there. We can just stick this in our calculator and get the answer, no problem. Okay, so we have a half times 15 times 15 over 4. Okay, that gives us 225 out of 8, over 8, sorry, and which gives us, if we, 28.125. If you want to show it like this as a mixed number, you can press this, I think. 28 and 1/8, you see? So it gives you 225, 225 over 8, which when you write it as an improper fraction is 28 and 1/8. Okay, square units. Okay, so there's the answer to part C. I think that was the end. Yeah, that was the end. Okay, that was the last part of the question, I think. No D? Yeah, okay. That's fine. So that is the conclusion to this question. I hope that was clear. Okay, so the first part of the question, just to recap, we wanted to find or prove that this crosses the x-axis at one point. Something crosses the x-axis, whatever it is, any formula, it crosses the x-axis when y equals 0. So you equate, you replace the y with 0, and you solve for x here. We could only find one solution for x equals 0. The other part that came from it has no solution. So it only crosses the x-axis at one point. We proved that. Part B said find the equation for the normal at the point P. So we found the gradient of the curve at the point P, and therefore we found the gradient of the perpendicular line, because the normal is perpendicular to the tangent at that point, and we use the equation for the straight line to find the equation of the normal. And for part C, we found where the curve, where this line crosses the x-axis and the y-axis, and we found the area, the triangle that it makes with the origin. We found its area and showed what it was supposed to be, and there's the answer to the question. Other questions from this particular paper, from this Solomon I paper, from the Solomon collection of P1, will be found in the playlist that will appear over here. Other questions from the end of topic worksheet number 8 on integration from P1 can be found in the playlist over here. Other questions from integration of P1 in general, of this is all Excel stuff, can be found over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.